Thursday and Friday, we looked at the volumes of prisms. How do you get the volume of a prism? See, our brain is reset. How do you get the volume of a prism? Connor?
Area of the base times height.
Area of the base times height. Remember, that's a capital E. So the volume equals the area of the base times the height of the prisms. There's often going to be a height in the area of the base too, right? Because if the base is a trapezoid, there's a height for the trapezoid. If it's a triangle, there's a height for the triangle. This H stands for the height of the whole prism. So keep that straight. The kids are having a disconnect on that. Now you got pretty good on Friday. You got everything straightened out. You're finding the volume of some planed prisms pretty good. Today, we add the complexity of prisms whose bases aren't simple shapes anymore. Is the front of this prism that we're looking at here, is it a trapezoid?
Oh,
Ethan, why do you say it's not?
because it has more than, what is it?
Yeah, it actually has 5 sides. 1, 2, 3, 4, 5. It's got 5 sides, so it's not just a trapezoid. So any ideas of how we could handle this one? Any ideas? Kelly?
You can, because you can see there's like, it's like a square thing, but it's not, it's a rectangle. So where that line comes, you can like cut it across and make
You want to come up here and draw a line? So kind of like we did with two-dimensional shapes when we looked at them when they were made up, composite of several shapes. These are made up of several prisms. So Callie says if I look at it there, you can look at it like we have a rectangular prism with a trapezoidal prism sitting on top of it. So to get the volume of the total thing, what do you need to do? In general, what do you need to do? Kelly kind of set us up for it. What could we find first? Ethan?
The volume of the trapezoidal prism
Volume of the trapezoidal prism, the one that's sitting on top,
plus the volume of the cuboid.
plus the volume of the cuboid, the bottom of it. Now remember, when you find the volume of each of these things, you got to use the area of the base times the height of the whole thing. You got to find the volume of the trapezoidal one like that, and then you got to find the volume of the cuboid one, and then you add them together and you get your full volume. Okay? So it's like taking what we did in 2 dimensions and turning it into a 3-dimensional problem. Get it? You are going to do this with your partner, so we're not going to go through all of the calculations right now. Okay? Let's look at another one. The bottom one you have on your note sheet there. Looks like this. Let's talk about a game plan for this type of thing. What does it seem like? What does it seem like? Rhea?
3 rectangular prisms.
3 rectangular prisms. So like you could cut it here, and you'd have 1, 2, and 3 maybe? Okay, so Rhea proposed maybe like cutting it here, and then you have 1, 2, and 3 prisms. That's true, Rhea, but I think there's actually a slicker way to do it also. You think back to what we did with 2 dimensions, what could we do here? Lena?
You get like the whole cube and then you subtract that little cuboid in the middle.
Subtract the little cuboid in the middle. So find the volume of this big block, the whole thing, and subtract what, Lena?
The empty space.
Subtract the empty space that's in the middle of it. The space cuboid, we'll call it. I think in the end it's an easier calculation because it's pretty easy to find these total dimensions to get that big cube. And then same thing with the missing space in the middle, it's like a cuboid's been pulled out of it. So this is a really quick and straightforward way of doing it. Again, to find the volume of the cuboid, you got to do the area of the base times the height of the prism. Questions? All right, again, I'll let you just do one like this with your partner rather than us going through the calculations here. So you got some game plans as to how to look at these composite prisms, okay? All right, that's what you're going to do today by doing these problems, right? Now, some of you are in faster teams, and some of you, so you kind of get to work hopefully with somebody who's at your similar speed. Starting on page 205, following my direction, basketball style. All right? All right, let's go.